Good morning, everyone. This is uh, V. Babu Ravapati from SESI Institute of Technology and Engineering, which is affiliated to JNTU Kakinada. Today, I'm going to give you a brief introduction about industrial robotics subject, which is taken from the JNTUK syllabus. The course objectives of this industrial robotics is we have four course objectives. So, first among them is to give students practice in applying the knowledge of the students of mathematics, science, and engineering, and to expand this knowledge into the vast area of robotics. Whatever they have, we want to expand that knowledge to the vast area of robotics. That is the first objective. Second one, students will be exposed to the concepts of robot kinematics, dynamics, and trajectory planning. By this course, students will be exposed to robot kinematics and robot dynamics and robot trajectory planning. Trajectory planning here is nothing but the about the trajectory and path which you already studied in the intermediate level. Okay, the same will be applied here. And then third one is mathematical approach to explain how the robot arm motion can be described. This is the third one. And fourth one, students will understand the functioning of sensors and actuators, which we are going to use in robots. And if you observe the syllabus, this is the syllabus. These are the first three units of the syllabus. In the first unit, we are having the introduction, and where we are going to have the explanation in detail about the robotics and then automation and robotics and CAD CAM. And then they are all different. In some people, they may think that those who don't have any knowledge in robotics, they may think automation is robotics. In some cases, they may think CAD CAM as robotics. But we have differences. Automation is different from robotics. CAD CAM is different from robotics. And what we have robotics and present and future applications of robots and at present where we are using those robots and in future what are maybe the applications in which areas we are having the exposure of robotics. Then classification of robots by coordinate system and control system. That is the first unit. We'll be knowing what is the coordinate system and what is the control system. We'll be knowing in detail later in due course. In the second unit, we are covering components of the industrial robotics. There, we are having the explanation about functional line diagram representation of robot arms, common types of arms, okay, components, architecture, number of degrees of freedom the robot can have, okay, requirements and challenges of end effector. End effector is a kind of robot end effector. It may be a holder or it may be a gripper which grips the objects. Okay, it may be a tool. End effector may be a tool. Okay, maybe in the case of it is doing any welding operation, end effector is a torch. Okay, maybe a in the case of drilling robot, end effector is a drill bit. If it is used for assembling process, it requires to have hold the objects, finished and semi-finished goods, it has to hold it. So at that time the end effector is a gripper. And then determination of the end effector, comparison of electrical, hydraulic, and pneumatic types of locomotion devices. These are covered in second unit. The third unit, motion analysis, will be having the homogeneous transformation, which is explained in the third unit itself, which is applicable for rotation and translation. We'll be knowing about what is rotation, what is translation, and the problems related to the rotation and translation. And then we are having the manipulator kinematics. So in this we cover some specifications of matrices, DH notation. DH in the sense Denovitt-Hartenberg notation of joint coordinates and world coordinates. And forward and inverse kinematics also will be knowing in the third unit. In the fourth unit, we'll be having differential transformation and manipulators, Jacobian, and then problems related to these. We'll be knowing about the dynamics. In the dynamics, two are covered majorly, and those two are Lagrangian Euler and then Newton Euler, and problems related to those two. In the fifth unit, we'll be covering and path planning and trajectory planning, and then skew motion, joint integrated motion, straight line motion, these things. And then we'll be knowing about the robot programming, the languages available and the software packages available, and how we are going to plan the path with the help of the robot programming. And then in the sixth unit, we'll be having the robot actuators and feedback components. So some small idea we gave in the second unit, and then now we are having the detailed explanation about robot actuators and then sensors also. Feedback components are nothing but the sensors. So the actuators classification, pneumatic, hydraulic, electric classification we'll be studying, and components, feedback components will be studying the position sensor and the velocity sensors. In addition to this, we are also knowing the robot applications in manufacturing, and we'll be studying more about the material transfer, how the robot function line will be there if it is a material transferring robot. If the robot is used for the application of the spray painting, what is the robot, how it look like, and what is the function line representation that will be there. If it is a the robot is utilized for the application of assembly and inspection, how the robot is. Those will study in the sixth unit. And here we are having the course outcomes. Upon completion of this course, students are able to identify the first one. We'll see identify various robot configuration and components that we covered in the first unit and the second unit. And then we are having the second course outcome. Select appropriate actuator and sensors for a robot based on specific application that we covered in the sixth unit. The third one is carry out kinematic and dynamic analysis for simple serial kinematic chains. So simple serial kinematic chain is nothing but a robot of different robot. And about that, we are going to knowing about the kinematics and dynamic analysis that we cover in third unit and the fourth unit. And then perform trajectory planning, fourth one, perform trajectory planning for a manipulator by avoiding obstacles. This we cover in the fourth unit. Not fourth unit, fifth unit of the syllabus. And then textbooks um, we recommend is Industrial Robotics by Grover is one textbook where we will cover first unit, then second unit, and then last unit, sixth unit. First, second, and sixth units will be covered in the Grover textbook. And Robotics and Control is the second book. And for this, we'll be taking the third unit and fourth units will be covered in this second unit, the second textbook. And then fifth unit, entire fifth unit will be covered in Robotics by Saeed Biniku. These three are important. And we are having the reference books also. We'll purchase any, or otherwise we'll refer to library. And these are the references we are having. Just we'll see the basics of robots. Definition we'll see, and then which branches are uh, covered to establish or to construct a robot, and what are the engineering knowledge are required that we'll see here, and some basic laws, and where exactly we'll use these robots we'll see. Briefly we'll see. Then coming to definition of a robot, several people define robots in several ways. We are having an institute, RIA, where the abbreviation for RA is Robotics Industry Association. They defined it as reprogrammable multifunctional manipulator. So it's a reprogrammable. We can do several times, like program. It can be done several times, reprogrammable. Then multifunctional. It's not single functional. It's a multifunctional manipulator. Manipulator is nothing but the robot. Okay, designed to move material. It may be any kind of material, maybe iron material, wooden material, glass material, anything. Move material, parts. It may be tool or anything. Okay, tools are some specialized devices through variable programmed motion for a variety of tasks. That is the definition of a robot given by Robotics Industry Association. And this is required to have the knowledge in mechanical engineering. We are concerned primarily with the manipulator, mobile robot design, kinematics, dynamics, compliance, and actuation. Okay. And for electrical engineering knowledge is also required primarily with the actuation, like electronic interfacing to computers and sensors, and control algorithms. Then we need to have the computer science knowledge and concerned primarily with robot programming, planning, and intelligent behavior. So these three groups of engineering are taking this subject, industrial robot, as an open elective, and this is there as open elective in some of the autonomous engineering colleges as well as in the JNTU Kakinada also. Then we'll see the basic laws of robotics. Asimov proposed three laws of robotics. We'll see who is Asimov. Asimov, or whether it is a person or maybe a company. We'll see those things in detail later. And these laws we require to know. So the first one is robot may not injure a human being. Robot should not injure. The injury in the sense should not harm a human being, or through inaction allow a human being to come to harm. uh, while the robot is playing its action, okay, it should not harm a human being. That is the first and foremost important law that a robot has to um, agree, okay, to run in the regular existence. And law 2, a robot must obey the orders given to it by human beings. Whatever the orders we are going to give, those robot those orders has to be obeyed by the robot, except there is an exception here, except where such orders would conflict with the first law. These orders will conflict with the first law. What are the first laws we are having? If that conflicts the first law, then it should not be a robot. So that is the case we are having. So what is the conflict with the first one? So it should not harm any human being. That is the first law. So if it is harming the first human being, any human being, then it won't get the completion of law 2. It's not executed with the law 2. So there also uh, the robot existence is a problem. So it should obey the law 2 also. And what is the law 3 we are having? A robot must protect its own existence. It must protect its own existence. So these are the laws of robotics. Then what can robots do? So these are the simple examples. So general motto we'll see where the robots can be applied is like to have some small knowledge. I have given three areas, okay, where human cannot enter and human uh, can enter and not accepting, and human repeated doing job is not possible with the same kind of effect. That these three will say an example. The first one is where the human's entrance is a dangerous one. So that means like if you take the case of a nuclear power plant where inside the nuclear power plant, once if a human being want to enter inside, where it's very dangerous to the human being. So there we can place a robot where it requires to be done, what the human being required to be done, that will be replaced by a robot. So here if you observe, this is a circulating pump housing which is there in the nuclear power plant. There there the people established a robot where it is um, doing the human beings work. This is the first application. The second one is where the second one is repetitive works of human being become some monotony for the human beings, like repetitive jobs. If a person required to do the job continuously for long time, it may be a boring one, or not perfect throughout the day. So at that time, we'll establish a robot where it can perform much better than human being. In the third one, if you observe, where the robot is are established or manufactured to wash the washrooms, to clean the washrooms. So this is another example. So these are the areas where the third one, if you see, uh, no one wants to clean the washrooms of any industry, or maybe any factory, or maybe at home purpose also. So at that time, we'll install a robot where it cleans the washrooms. So these areas will cover the robots to be installed. Okay, thank you. This is the introduction for industrial robotics by V. Babu Rao Pati. Thank you. Thank you very much.